Hello students, welcome to my channel. This is Chemistry Without Fear. If you are studying class 11 chemistry chapter number 1, this video will make your concept crystal clear. Today we will understand atomic masses, molecular mass, formula mass, mole concept, limiting reagent, concentration of solutions, mass percentage, mole fraction, molarity, molality and its derivative. By the end of this video, you will solve numerical easily. So watch till the end. Let's get started. First of all, atomic and molecular masses. Atomic mass is the mass of one atom of an element. It is measured in a atomic mass unit. Its AMU has been replaced by U. Okay? For example, atomic mass of hydrogen is 1U, carbon is 12U, and then oxygen is the 16U. These values are taken from the periodic table. Important is atomic mass is relative mass compared to the 1 by 12th mass of carbon 12. Okay? Molecular mass. Molecular mass is the sum of atomic masses of all atoms in the molecules. It is obtained by multiplying the atomic mass of each element by the number of its atom and adding them together. For example, it's water. Water atomic mass of hydrogen is 1 and atomic mass of oxygen is 60. Molecular mass of H2O, its number of 2 is hydrogen, and then atomic mass of hydrogen is 1, add 6, oxygen has a 16. So our molecular mass of water is a 18U. And then another example we called as CO2. In this, carbon has a 12 atomic mass, oxygen has a 16. 16 to the 32 plus 12 is equal to 44U. Okay. This is our water example you see in the screen. Formula unit mass is the empirical formula of the formula mass, right? What is formula mass is the used in an ionic compound. For example, NaCl. In the NaCl, sodium has a 23 atomic mass and chlorine has a 35.5. Formula mass of its NaCl means 23 plus 35.5 is equal to 58.5 U. This is the NaCl formula mass. Formula mass means it used on only ionic, means Na plus and Cl minus. Okay, so remember molecular mass has for a covalent compound and formula mass has it for a ionic compound. Please remember, this is very important. Next, mole concept, very important. Mole is a unit to count particles like an atom or a molecules. Here 1 mole is equal to 6.022 into 10 raised to 23 particles. Okay. The mass of 1 mole of the substance in gram is called its molar mass. Number of moles. How can count the number of moles? Number of moles is equal to given mass divided by molecular mass. or a molar mass, or a number of particles is equal to moles into 6.022 into 10 raised to 23. Every moles into 6 Avogadro number, you can give a number of particles. Okay, for example, how many moles, let's take one example. How many moles are present in 18 gram of water? This is our question, right? The molar mass of water is 18 gram per mole, and then moles means 18 gram given mass divided by molecular mass, it's 18, so our mole is 1. So 18 gram of water contain 1 mole of molecule. Right? Remember? Then next, this is our mole concept. You can remember, in a volume of a gas in a liquid at standard temperature pressure divided by 22.4 liter, or even number of mass moles, you can multiply by 22.4 liters. You can iterate under standard temperature and pressure conditions. 1 mole of any gases occupy a constant volume of a 22.4 liter. This is very important for your numericals. Then next, limiting reagent. Limiting reagent is the reactant that gets finished first and stop the reactions. For example, we can take water molecule, right? 2 hydrogen plus oxygen, and it gives 2H2. Suppose you have a 4 moles of H2 and 1 mole of O2. Here in this example, we give a 2 moles of H2 react with 1 mole of O2, oxygen, right? Dioxide. So for the 4 moles of H2, we need a 2 mole of O2, but we only have a 1 mole of O2. So our oxygen is a limited, so it's a limiting reagent, right? Reaction will stop when O2 is finished. Okay, let's get read. When any reaction is carried out, if the reactant are not present in the amount of as required by the balanced chemical reactions, in which situation one reactant is in excess over the other, the reactant which is present in the lesser amount gets consumed after some time, and after that no further reactions take place, whatever be the amount of the other reactant present. Okay, limiting reagent means the reactant used up first in the chemical reactions, and excess reagent means the reactant present in a quantities greater than the necessary to react with the quantity of the limiting reagent. Okay, next, concentration in the solutions. Concentration means amount of solute present in given amount of solutions. There are many ways to express concentrations based on mass, based on moles. Now let's understand each of Okay, and the concentration of solution expressed in a 4 different ways: mass, percent, mole fractions, molarity or molality also. Here solute is the given uh, reactant is small amount, it's called a solute, or whenever solute get dissolved in a solvent. Here our sucrose is a table sugar for a solute, and water is our solvent and it's give a water solvent. Here concentration is equal to solute divided by solvent. See the figure and express this. Next, mass percentage. Mass percentage means is equal to mass of solute divided by mass of solutions into 100. Formula you can see here. Total mass of solution is, for example, we can take our total mass of solutions. For example, we can take a 10 gram of salt is dissolved in 90 gram of water. Total mass of solution means 100 gram. How can measure? Mass percentage 10 gram our solute, and total mass of solution means 100. How can 100? 90 plus 10, we get a solutions, right? Salt plus water, and then into 100. So we can take mass percentage is 10%. Okay, that's very easy for you. Next, mole fractions. Mole fractions means moles of component divided by total moles. Okay, if as it is no unit, it is defined as a ratio of number of moles of particular component to the total number of moles of the solution. If a substance A dissolved in a substance B and their number of moles are small na and n small n b respectively, then the mole fractions of A and B are given as your slides is XA or XB. You can remember XA is equal to divide NA small a, this represent of solution A, divide by total, it's Na plus Nb, and then both are present, total number of moles is 1. Please remember. Let's take one example. If moles of A is equal to 2 and B has a 3, so total mole of 5. So mole fractions, I can take off mole fractions. A is 2, right? 2 divided by total is 5, it's 0.4. And then we take a mole fractions of B, so it's 3 divided by 5. What can I? 6, it's 0.6. So total is a mole fraction of A and mole fraction of B is equal to 1. It's 0.4 plus 0.6 is equal to 1. Every time we go get this number. Or if you get more than 2 substance dissolved in your solutions, so all total mole fractions only have a 1. You can must remember, if we get a mole fraction of A, then 1 minus 0.4, you will get a B mole fraction. It's 0.6. It's very easy in exam time. Okay, let's go to the next. This is our molarity. Very important. Molarity means moles of solute per liter of the solutions. It is the most widely used unit and denoted by its capital M. It is defined as the number of moles of the solute in a 1 liter of the solution. Therefore, our formula is molarity is equal to moles of solute divided by volume of solutions. Its unit is mole of solute divided by volume we can calculate a liter, or we can say as capital M. Okay, for example, 1 mole of solute in a 1 liter solution, so our molarity is 1 molar. Important is molarity depends on a temperature because volume change with a temperature. Okay, you can see in this formula in the slide. Next we remember of molality. Here molarity, it's denoted by volume of solutions, and here molality. Molality means moles of solute per kg of the solvent. Here we can use the solutions. Here solvent. Please don't forget it. It is defined as the number of moles of a solute present in a 1 kg of the solvent. Molarity formula is equal to moles of solute divided by mass of solvent in a kg. Unit mole per kg, right? Important is molality does not depend on a temperature because mass does not change. Okay, you can fix this. Next, two main concentrations types molarity. This is based on volume, and molality, this is based on mass. Remember, temperature change affect molarity but not molality. Okay, define molarity. It is the most widely used unit, is denoted by capital M, and the molality is defined as the number of moles of solute present in 1 kilogram of solvent. It is denoted by small m, right? Here it is defined as the number of moles of solute upon volume of a solution in a liter. Here molarity, in molarity we call as a kg. Molarity is no number of moles is solute divided by volume of solution in liter, and the molarity formula is number of moles in solute divided by mass of solvent in kilogram. Molarity is not preferred and molality is preferred. And then temperature difference also we can remember. Okay, go to the next slide. This is concept in a molarity. Numerical tricks. First of all, if given mass of solute, volume, or in ml, let's explain this. If given mass of solute, volume in milliliter. Step number 1, you can follow. Convert mass into moles. This is first step. What the formula is? Moles is equal to mass divided by molar mass. Okay. Second step. Second step is convert milliliter into liter. What is the formula? 1000 milliliter is equal to 1 liter. And then third step is apply our formula. What is apply of a formula? In the molarity, capital M, number of moles divided by solutions in a liter, right? Let's get one example also. Find the molarity of 5 gram NaCl dissolved in 500 ml solutions, right? First, molar mass of NaCl. What is that? We can calculate it before. Sodium has a, please remember, give me the answer. Sodium has a, what is molecular mass? It's 23 and chlorine has a 35.5. So its molecular mass is 58.5 U. Please remember before your exam. Okay, let's go to the next step. What is our moles? 5 gram given mass divided by total. Our molar mass of NaCl is 58.5. Convert into milliliter into liter. Liter is 0.5 liter, right? So molar is a 5 into 58.5 into our molar mass in liter is 0.5. You can calculate and get the answer. Okay. Here, in some cases, to find the mass of concentration, compound, volume of compounds, mass of the second compound and volume of the second compound will be given. In that case, we apply the formula of M1V1 is equal to M2V2. This formula used in your practical also. Please remember, this is very important. Another very important formula used in a molarity is the finding molarity using density. The formula is capital M is equal to percentage into density into 10 by mass. Example questions given here. Commercially available sulfuric acid contains 93% by the mass and has a density of 1.84 gram per centimeter cube. Calculate the molarity of the solution and the volume of concentrated acid required to prepare 2.5 milliliter of 0.50 molar of H2SO4. This question, if you cannot understand, please read carefully first of all your questions and then get solved. Okay. Keep a solutions. What is the molarity of solutions containing? 0.32, right, moles of NaCl in a 3.4 liters. So we can calculate molarity 0.32 moles of NaCl divided by 3.4 liter. Our answer is 0.094 molar NaCl. If this example question you can remember, please comment on below the video. I can explain this. Example of molarity. What is the molality of solutions consisting of a 1.34 milliliter of carbon tetrachloride CCl4? Its density given in the example 1.59 gram per milliliter in 65.0 milliliter of methylene chloride means CH2Cl2. Given also in this Density 1.33 gram per milliliter. Solution also given here. First of all, for our first step, moles of CCl4, it's 1.34 times 1.59 milliliter. It's our density. Okay, the answer is 2.1306 gram. Divide by total. So we can find the mole, and then next calculate the mass of methylene chloride. We can 65.0 milliliter and times of the density 1.33. So we can calculate 86.45 grams, convert into kg, and then calculate the molality. It's given solute mass is 0.013851 moles divided by our solute divide by solutions in a kg, because we calculate a molality. What about its weight? 0.08645 kg. You can give answer 0.160 molar, right? Molarity we can molar, and molality we can molar. Molarity we can capital M, and molality we can use a small m. Please remember. Okay, quick revision. Atomic mass, we can a mass of one atom. Molecular mass, sum of atomic mass. Formula mass, ionic compound mass 1 mole is equal to 6.022 into 10 raised to 23. In the limiting reactant that finished first, this is our limiting reagent. Mass percentage based on mass, mole fractions, ratio of moles, molarity, mole per liter, and molality, moles per kg. If this video helped you understand chapter number 1 clearly, like the video, share with your friends, and subscribe for more class 11 chemistry video. Comment below which chapter you want to next. See you in the next video. Thank you.